Right, the purpose of this video is to talk about how you can use the idea of transformations to find the equation of virtually any function just from the graph. For example, what I see here is an absolute value function. All I have to do is identify first any shifting transformations that may have occurred, and I can see that if I was using the walk it home method, that I'm starting at the vertex, I have to walk it down 3, so I take away 3 from all the y's to get it to the origin, and I take away 1 from all the x's to get it to the origin, and I would be able to write this. Well, notice is the a value, which is what causes a vertical stretch. I still haven't figured that out yet, but at least I figured out any of the shifting transformations, and all I have to do is add 3 to both sides, and I've got that sorted out. And one thing we can notice is with the walk it home method, we get the y part on the left side. I add it over to the right side in order to actually make this look more functioning. So this is an adaptation or modification of walk it home. Anyway, we still have to find the a value. Now in order to do so, I just start at the vertex and I walk over 1. Then I just have to walk up or down to wherever the graph is, and however far up I go, in this case it was 2, well, that's your a value. So you substitute that into the equation as shown, and that will be the function equation. Alternative to that, slope-ish kind of method for finding a, you could just find any point on the graph and fill it into the equation. So what you can see here, for example, is I know the x, I know the y, I know the h, I know the k. All I have to do is solve for a, and once I do, I find that a equals 2. So I could have used that method for finding a. Now, we can see that regardless of which approach, I should find a point on the graph and make sure that it is a solution to my equation. Or I could check with Desmos or a graphing calculator. But make sure that you've actually found the correct equation and don't just assume that you're right, because you never make mistakes. Another function, this one looks like a graph of y equals x cubed, so I know it's going to have the following format. I don't know h, I don't know k, I don't know a, but I can figure it out. Starters, I find out where the central point, or the vertex-ish kind of thing, is, and that gives me my h and k values. So in this case, we walked to the right 1, so we're going to have x minus 1 cubed, and then I'm going to went up 3, so that's plus 3. Now to find the a value, I could do the vertex method, so I go from the vertex over 1 up 2, and the a value turns out to be 2 here. So once again, I replace the a value with 2. That should be the equation of my line. To verify, pick a number for x. Now you'll notice here I chose x equals a half, just to remind you that fractions do exist, and they're not as bad as you think. So I substitute the appropriate value into my equation, and I find that after cubing, and incidentally, we should be clear about this, when you cube negative 1/2, it becomes negative 1/8, because a half times a half is a quarter, and a quarter times a half is an eighth, and a negative is negative in the end when we multiply. So 2 times negative 1/8 is negative 1/4. Add that to 3, and we get 2 3/4. And just to verify, that is indeed a point on my graph, because if we start over 1/2 and we go up 2 3/4, here's 2 and 1 2 3/4. That's the point on my graph. So I'm convinced that this equation is in fact correct, because I've done everything I can, but just in case I'm not, I'll go to Desmos, graph it, and make sure that my equation produces the graph shown. Now, this is an example of a reciprocal function. It has been shifted from the origin, and that's clear. It might be tricky for some students to figure out exactly how far left and exactly how far down it went. So what I'm going to do is I'm going to draw in the asymptotes. We've got the vertical and horizontal asymptotes. And where the asymptotes cross, that's going to be the sort of new center, the new origin here. So I can use that to figure out my h and k values and use them to fill out this particular format. So instead of taking the square root or the absolute value or cubing here, I'm taking the reciprocal, but first I'm going to add 2, take the reciprocal of that result, multiply by a, and then subtract 3. To find the a value, it's just the same as before. You simply start at the fake origin, you move over 1, up until you hit the graph, and however high up you went, that'll be your a value. So in this case, my a value is 3. I put it in the appropriate place in the equation. Here I should do one more step though. 3 times 1 over x plus 2 is 3 over x plus 2. That's how you multiply fractions. So, to check, I found a point on the graph, negative 5, negative 4. I substitute that into the equation, and it actually is correct, and I'm done. And finally, a square root graph. This is clearly a square root function. It's going to follow the format as shown. We'll see the format in just a moment, but all I noticed is there's a horizontal shift. There is no vertical shift, so I went to the left 4, and I substitute that into the format. And so I know no vertical shift, so the k is 0, and I went left 4, so the h is -4, which is minus -4 gives me +4. Anyway, I still need to know the a value. Just as before, I go over 1, and this time I have to go down until I reach the graph, and it appears as though I had to go down 1/2 to get there, so my a value is actually -1/2. Just to make sure, I check with a point on the graph, and 0, -1 is in fact a point on my graph. It's right there. So here's how I check. So if you actually go back and review this video, you'll see that no matter what the function I'm dealing with, I am going to have the same exact model. I find out where the graph has been shifted, I find out how the graph has been stretched or compressed or flipped, and I indicate that using numbers in my equation. Hope this was helpful. Have a nice day.